everyone, it's February 19th. Again, didn't do it yesterday, so let's do it today. With a fresh mind and a full belly. Ate something really nice earlier. Alright, minimizing deviation in array. Has 51% passing rate, so I kind of think it's not too hard. And based on the fact that I upvoted it, it must be something I've done before, which if you take a look, was not that bad. Look at this. Wow, that's like a year ago. January 30th, 2021. Alright, you're given an array, nums of n positive integers. You can perform two types of operations on any element of the array any number of times. If it's even, divide it by 2. If it's odd, multiply by 2. The deviation of the array is the maximum difference between any two elements in the array. Return the minimum deviations the array can have after performing some number of operations. So we're not minimizing the number of operations, we're minimizing the deviation. So in here, I can multiply by 2, divide by 2, so that'll be 1. For this one, I can, well, I actually don't know, multiply by 2, divide, wait. Or even we divide, odd we multiply. So this one divide by 2 and divide by 2, multiply, so it'll be 3. I see. Okay, I do not remember this one at all, so it's a fresh new problem to solve. Alright, so what are we looking for? What we're looking for is after some operation, they need to be as close to each other as possible. We want to find a minimum deviation, right? Minimum deviation. Let's try dp, right? Let's try dp on this. So basically, I would say each number, we either do something or we don't do something, right? Okay, if we do something or we don't do something. And if I have two values, that's simplified. If I have two values. If both value are odd, then there's nothing we can do. If both values are odd, the only thing we can do is multiply. Well, we can do the smaller value. Right? The smaller value we can multiply. So if the smaller is odd, then the smaller value multiply will always be better. And if the bigger value is even, we always divide. But what if we have a small value that's even and a bigger value that's odd? Then there's no way we can do. So we just leave them alone, right? If we have two values, then we see we want a smaller value to be bigger, or the bigger value to get smaller. So we see if the smaller value is even, then we cannot, because even will get smaller, and a bigger value, if it's odd, that's still not. But if it's the other way around, we can multiply, whatnot, to get them closer, right? Or maybe the bigger value can divide and the small value can multiply. Okay, so it doesn't matter the order, right? It doesn't matter the order. The biggest difference right now is the largest value and the smallest value, right? If we find that, and let's say the goal is to minimize these. Okay, so the first example, we have 1 and 4, right? I want to minimize these. How do we minimize? I say I can multiply 1 by 2. Yeah, if we multiply 1 by 2, then the smallest smallest value is 2 and biggest value is 4, right? So that's our difference, and now is 2. So I say the bigger value we can divide by 2, so that's 2. And now the biggest value is 3, and the smallest value is, the biggest value is 3, small value is 2. So we have 2 and 3. And the small is an even number, which only go down, and 3 is an odd number, can only go up, so there's no way to go. So we'll say that's it. Huh. Are you saying that we need to have a scheme to keep popping out the small value and keep popping out the big value? How do we do that? I mean, we can use a heap, but heap can only pop out, let's say, the smaller value. How about the biggest value? What do we do with the biggest value? Well, the biggest value if it's an odd, then there's no way we can do anything about it, right? If it's an odd, then how about this? Let's do a max heap, right? So we pop out the biggest value, and for the biggest value, we want to reduce it, right? We want to reduce it, and we say if it's an even, we divide by 2, and then pop out the biggest. And we divide by 2 till we cannot divide anymore, which means if we hit an even value, and then we, the same thing, we put it into a min heap. Come on, internet. Struggling. Then we put in the min heap, and the min value coming out. Yeah, we go a max heap, so we kind of reduce the maximum value as much as we can until we hit a point, right, which is an odd value, so we cannot keep going down. So we keep track of that thing. So that thing will not be, as the largest value, we can never be smaller than that. And then we go a min heap. So every time we get a min value, and if the min value is smaller than the max value, then we multiply by 2. All right, multiply by 2, and hope is that will not be if the 2 is differ by, hold on, let me run some math. If a plus 1 equals b, right, and we see b is the largest value, which is also an odd value. If it times 2, 2a plus 2, right? So b minus a is equal to 1. How about b minus 2a? Well, b minus 2a, because b is equal to, so a is equal to b minus 1. So that's 2b minus 2. So b minus this plus 2. So that's 2 minus b. Which means if a is bigger, if 2 times a is smaller than b, then definitely gets the deviation smaller. But if 2a is bigger than b, it is possible that it gets really, really big, right? So if I double it, if I double the small value, which causes the deviation to grow bigger, then we don't do it. We can just pop it and find the, now we don't have to find the next one. If it's the smallest and I double it, it's already creating more than if it's something bigger, which is this one plus something, and we double it, it can be even larger, right? Okay, so we reduce the largest to a point where we cannot reduce anymore, and then we try to increase on the small. Does that work? Does that work? I mean, it does work for the first test case. The 4 will be divided into 2, and then 3 will pop out. But 3 we cannot eliminate anymore. So now we go to 1, and 1 if we double, that is that actually gets us closer. So we 1 double, and then we do it again. There'll be 2 coming out, and 2 times 2 is 4. 4 and 3. So that's no difference. Right? Hold on. Could it be like I am smaller but I double it? Yeah, I think I can. Like 5 and 8. Right? 5 and 8. If it's 5 and 8, no, it cannot be 8. Let's say 9. 5 and 9, right? 5 and 5 cannot do 4. 4 and 9. 6 and 9. Huh. Hold a sec. Hold a sec. Even number can double. An odd number. So if it's even, it's odd number on the top. Even number is slow, so they will have at least 1 in between, right? So that would be 2k, and that's 2k plus 1. In that situation, if I double it, that would be 4k. It would be 4k minus 2k minus 1. It could be bigger, right? But could it be that after I double, I actually make the difference smaller? I think it's definitely possible. About 7. Yes, how about 4 and no? Yes, 4 and 7, right? 4 and 7. So 4, if I double it, becomes 8. Now the difference becomes 1, right? And now, then I need to keep 8 instead of keep 7. Here's the idea, right? So we reduce. We get the largest value reduced to a certain level, and everybody now the goal is just to minimize their difference to this. So we don't care about the largest anymore. So for each small even value, we just multiply by 2, and we can try multiply multiple times by 2 until its difference, like the next one, will make it bigger. So if every time we can reduce the difference, keep doing it. But hold on, but now then that is not the biggest value anymore, right? If you have 4 and 7, if we do one round, that's gonna be 7 and 8. But 8 becomes the largest value, which we shall take it, right? Which we shall take it. We take 8 is the largest value, but then all the things we've done previously is based on 7. How do we reconcile that? Wait, hold on. It cannot be even, it has to be odd. Only odd number. Oh, I was wrong. Only odd number can multiply by 2. And after you multiply by 2, you cannot multiply it again. You can only multiply it once. Because you are odd, you multiply by 2, they become even. Then you got stuck. You cannot keep growing. So all the values growing can only grow once, but it can reduce multiple times. So every value can grow only once. And after it grow, then we'll come back down to the same value. So there's no more change. Okay. So again, let's do the same thing. We reduce. Okay. We reduce. Or maybe because increase. How about we increase first? We get the smallest value. And if the smallest value is an even value, then there's no way. Right? If the smallest value is even, there's no way. If the smallest value is an odd, then we can increase it. And that's how we just increase it once. That's the only thing we can do. We increase it once. And then what? Should I decrease or increase? I'm thinking again. So we have the largest value, and then we can use a heap to divide. So we can bring the largest value down. We sort it first, or we put in a heap. We bring the largest value down until the largest value is an odd number, which means we cannot do anything more about it. And then we go from small value up. And for each small value, we want to see if the smallest value is an even value, then there's no way we can do. We cannot do anything. But if it's an odd value, we can multiply by 2 and observe if the difference gets smaller. And if it goes larger than the current one, yeah, that's the problem. What if I multiply by 2 and it becomes bigger? Hold on. What if because multiply can only do once. So let's say I just multiply everybody. Okay, 4, 2, 10, 26. I multiply everybody by 2. And then I bring it down. So no more multiplication. We just multiply everybody. And then we bring everything down. Okay, so the smallest value now is 2. Right? And then we're going to go, the biggest value is 20. And then we're going to bring it down. So that's going to be 10. Biggest value is 10 and bring it down to 5. We don't go up again because we're already finishing going up. And then next biggest value is 10. We'll bring it down to 5. The next biggest value is 6. We'll bring it down to 3. And no, that's 5. That's it. Let's try this. We find all the odd number, we multiply by 2. And then we start dividing. So this one will be 10. So 10, 2, 10, 8. So 10 will become 5. 8 will become 4. And that's it. So the difference is 3. I don't think I have a good proof, but I'm going to try to do it because I think the whole idea is for each number, right, it's even or odd. Even can only divide, odd can only multiply. And the question is, for the odd number, right, if I multiply, and that's it. And I can divide. So just multiply and divide, multiply and divide. That's just one direction we can go. So why not we just go everything multiply, right? Multiply. If it's too big, we can divide it. We can always divide it back, which is fine. That's why I say for the odd number, I just first multiply, right? And after multiply, now we have a new array. Then we're trying to minimize the biggest value, right? The biggest value, because eventually the actions on each number is either multiply or divide. And because I multiply on the odd numbers, if this multiplication is not necessary, then during the reduction phase, those numbers will be brought back down, right? Will be brought back. It's as if this value has not undergone any operations. I think this might work. This might work. All right. Try it our luck. I think the algorithm itself is not complicated. Come on, it's not complicated. We do need, I just import heap q, right? And what we need is I in range len nums if, and I don't like this, for I n in enumerate nums. Right, if n mod 2 if it's odd, then nums I time is equal to 2, right? So once it's done, we say heap q dot heapify nums, and we're going to say while heap q not heap q, while nums, oh shoot, we need a maximum heap, right? Dang it, a maximum heap. So this has to multiply minus 2, right? Else nums I don't know, multiply equal to minus 1. So I have to turn them into negative value. So then we can say the top, right, 0. While this, hold up, I'm not sure. Python has very weird way. That's a negative 5 mod 2 is 1. Negative 4 is 0. Okay, so if this mod 2, which means if this is equal to 0, right, then we say heap q dot heap, wait, is it push pop or pop push? No, that's just pop dot heap pop nums, right? Because that is an even value. Then we can divide it by 2. Then heap q dot heap push nums and push it back in, right? And then we check if it's this, we're coming blah blah blah. Once we're done, we're breaking out. Then we're gonna return nums 0 minus the minimum value. Minus the minimum value. So minus the, naturally this is going to be the maximum value, right? Nums. And honestly, this is a bigger negative minus a small negative. That's going to be negative, which means I am rather willing to do the other way around, which is maximum this minus this. Let's see. Alright, so I think these test cases do pass because I tested them already. 4, 1, 5, 20, and 3. And this one should be 3. The last one is 2, 10, 8. I remember. And there's 3. It's nums. Minimum deviation. Nums. Yeah, they pass. I think what I'm going to do is for some weird 1, 2, 1, 2, okay? Because Why not? 1, 1. Then like that. My test case is always like this. Okay. All right. Just try it. Just try it. See how it goes. They all pass. Oh, this gives me some boost, confidence boost. Let's add more. All right. So just how about this? Yeah, we did pushing some known values. Okay. It's a giant array of numbers. Oh, that's probably too much. All right. Let's try this. I have confidence. Let's do this. Let's see. Let's go. Let's go. Let's go. Ah, I said I have confidence and immediately got wrong. That's very unfortunate. 3 and 5. Output. Oh. Oh, yeah. I see. I didn't consider this. I multiply everything by 2 first. So it's 6 and 10. Right? Hold on. I multiply everybody by 2. So it's minus 6 and minus 10. And I heapify it. It comes out should be this. So it should be minus 6 and minus 5. And minus 6 is at a minus 6 is a minus 5. Hold on. This is not right. This is not right. Oh, I think it's I multiply everybody by 2, right? And then I shall have a big, and then I find out the biggest value, and I divide it by 2, right? And then minus 6 becomes the biggest. And that one divided by 2 again, and that's why it's wrong. So it becomes minus 3 and minus 5. That's why it gave me 2. Okay, that makes sense. That makes sense. How should we do this? So I think what we need to do is keep track of the biggest and the smallest value. That's what we need, right? We just keep track of the biggest and the smallest value. And how do we keep track of the biggest and smallest value? Now I have a min heap. I have a max heap, right? So I keep track of the biggest value. So when the biggest value gets popped out, I divide by 2, right? And I push it in, and the biggest value becomes the smallest value. That is the thing. The biggest value becomes the smallest value. Just remember, what we're doing is we're trying to bring the bigger value down, right? So the value is big, we want to bring it down. But if we bring this down, that it's smaller than the smallest value, then it's good, right? We should keep doing this. If it's smaller than the smallest value, if we bring it down, and the new one, we bring it down to smaller than the smallest value, then we are shrinking the range. But if it happens that the biggest value, when it brings us down, it becomes smaller than the smallest value. Okay? If it becomes smaller than the smallest value, then what happens? It becomes smaller than the smallest value. We update the smallest value. Right? we update the smallest value. Think about it. Everything multiplied by 2. I keep the smallest value, right? This is just a value. And then I pop the biggest, divided by 2, and we find the difference, right? And the biggest is larger than the smallest, and it's fine, we push it back in. It's fine, smaller doesn't change. And if we pop out, divide by 2, right? Yeah, we pop the biggest out. We need to find a baseline. Right? That should be the baseline. And then we pop it out, divide by 2, find the difference. I'll update that, and then we push it in. Come out, divide by 2, the next one, come out, the biggest one, come out. We find it once. Wait, hold on. So the biggest one, right? Find the difference, divide by 2, push it back in. Second time, biggest one, come out, minus, right? Then divide by 2. And every time divide by 2, I compare. If it's smaller, we swap. We swap to a new smaller one. So basically, just we keep popping out the bigger value, right? Until we cannot, the bigger value become odd. Until we cannot do that anymore. And every time we pop out a bigger value, this is the current biggest, right? And then we're trying to do it. And okay, let's try a different thing. Let's say I always store the mean, okay? And then this is while true, okay? And then as a result, because we want a minimum, so result is math.inf, okay? So import math. And then every time I'll say, actually, because it's that's actually max. Unfortunately, it's a max. Oh, the min and max kind of is reversed. Don't forget, it's reversed. So maximum does is actually the minimum. Okay, maximum does is actually the minimum. So now we can just say the max equal to heap q, right? Heap dot heap pop nums, right? The res equal to minimum res abs minimum this minus maximum this. Well, actually, it's maximum this minus minimum this, right? Doesn't matter. So we do abs, right? So that's the difference. So we record it, and after record it, we say if max n is an even value, then I'm going to push it in again, max n divided by 2. Else, if it's then we have nothing else to do, then we're going to break, right? So pushing in, and there's one more thing to do. I'm going to say max n divided equal to 2, right? And then I'm going to push it in, and then so minimum n shall equal to max, right? Because it's a negative value. So max minimum n and a max n. So if it's a divided by 2, and now I'm going to push it in and then update the minimum if necessary. and then comes back and do it again, we get the rest and check if it's not. And once we return, we just return rest. Then we pass this. And we pass all these. Okay, let's try this one. Okay. Show me. Show me. Come on. Come on. Come on. Nice. Very nice. Very, very nice. We did it. We did it. Wow. This is smoother than last time. Much smoother. We did hit one roadblock. But overall, it's not too bad. Okay, so what was the solution? Now I just realized one thing. We can create a new thing. That's fine. That's fine. This is okay. All right. So what should I say? So the first step is to multiply all the odd values, odd numbers, by 2. This is because all odd values can only be multiplied once. So let's just do that once. And afterwards, we will focus on reducing the max value, right, while keeping an eye on the difference, on the maximum deviation. Note that if an odd value is not supposed to be doubled, it will be reduced by half during the process of reducing the max values. Now, one key element to note is that during reduction, it is possible that that the mean value of the array might change. If that happens, we simply update the mean value, and we will keep reducing the max until we hit a max that is odd. Right, so the runtime will be O unlog n, right? Unlog n for the heapify. What heapify is log n. No, heapify is O unlog n, right? I don't remember. Heapify is O n, I think. Heapify is O n. And then we come in here and we pop, that's log n. And then if it's no good, so it's the worst case, we'll have to do this. So I think O log n is the runtime. Kind of. 944 edges, it runs better than last time. Okay, so I did it before. So this is either a solution I get myself, or I copied from the official solution. All right, let's take a look. Heap queue. Look at that. I say if this, I push it in. If not, I divide by 2. Wow, true. or pop min. I use a min heap, so I get out the minimum value. If this yeah, it's a similar idea. It's a very similar idea. I think I figured it out myself. As a slight difference is, I don't know why I use I. Smaller equal to num's I. I don't know. This, I don't have to, but it is possible to not use, not reverse it. We simply just, yeah, it's the same. Either we multiply the odd values by 2, or we can just divide the even values by 2, right? If we divide even values by 2, then we are obtaining the maximum. So we have the max value, and then we go the minimum value, right? So we heap q pop is the minimum value, and we multiply by 2 until we find a odd, an even, right? If we find the even, then we cannot do anymore. Yeah, it's the same. Nice. 76 test cases. How much is this time? I think it's the same. The difference is I didn't put I into it. That's why it's slightly faster. 76. Exactly. I can look at the discussion. Intuitions and flip. 2020. Yeah, I think this is a. I think this is a. How should I call it? A contest problem. Yeah, because you cannot do anything about it. The odd cannot be reduced. Increase the smallest number. Yes. Yes. Oh, I double all odd numbers first. Decrease large amount while it's even. Track the smallest number. Track the minimum difference between the top of the heap and the sum. While the top of the heap is even, remove it. Divide and put it back to the heap. Yep. It's exactly the same as this one. Exactly the same. Alright. That's why I didn't write anything, because it was the same solution. Alright, that's that. I think we are good to go. What do you want to do? Well, I want to save some brain power for tonight. So let's do an easy problem. So we have time. We only have 42 minutes in, so we can do an easy one. Oh, see that? From 51.6%, 0.3 to 51.6. That's my contribution. That's my contribution to make it slightly higher. Okay, all of these are SQL. We don't like. This is SQL as well. Contain duplicates. No, it's not. I've never done it before. Let's just do this one. Give an integer array, return true of any value at least twice, return false if every is distinct. Well, there are many ways to do this. What will be the fastest way? Set it, right? I think set will be the fastest way. Set will be on. Well, set will be one line, but also if you sort it as O(n) log n, right? And we don't want to sort. We can iterate through, push everything into a set, and then whenever we find something that we say that's bad, that can actually be faster. Like in this case, will be faster, right? Any other way. We can exclusive OR. Oh wait, no, you cannot exclusive OR. It didn't say two. Yeah, I think I'm gonna try these two, but I'm pretty sure they will come out similar performance. Sometimes it's nice just to hit some easy problems. And I want to increase the number of problems I solve. I have a goal. I want to solve 1,000. Right? Len nums is larger than len set nums. Right? Because if I say return true, yeah, this is true. Return false if every element is distinct, then these two will be equal, right? So that will be false. If we have, yeah, that's one. And then another solution is seen, right, equals set. And for n in nums, if n in seen, return false. No, return true. Otherwise, seen dot add n and then return true. So yeah, so I have two solutions. I'm actually gonna try this one first. Usually the first submission gives me the highest boost. What's up? That looks beautiful. You can eat it. Yeah, I think it's fine. Just in case, let's run through this. Oh, what the heck? Output true, true, true. Second one shall be false. Oh, second should be, hold on. Yeah, it should be false, but I return true. Why? Scene is empty. Scene dot add n. Next n come in. If that's two in scene. Oh, I shall return false. My bad. That was a stupid mistake. See, that's why we need to run this first. Otherwise, you're gonna lose 5 minutes. Always good habit. Okay, so we run this at this. How about this one? Which I hope will be faster. No. I wonder what if like it reversed it too. But this I think is the fastest we can go. I don't know. Like, what's your method? Possible solutions. Log in, O(n) hash set. Space-time trade-off. Ah, yeah, O(n). Yep. O(n), memory O(n). Okay, yeah, we have some fun. That'll be it. I'll see you guys tonight. I'll do the contest, and hopefully we have better luck. I'll see you guys tomorrow. No, tonight. Adios.